Okay. Welcome to our last section of Chapter 8. We're on Section 8.4, Example 1 on page 323. Listen, of all the chapters in the book, this one is the most awesome because it's actually applying the algebra you've been learning into a context that makes it kind of cool. So if we look at Example 1, it may seem kind of really difficult, but this is the purpose of your algebra. This is the reason why you are doing what you're doing. You're using it so that when you have problems like the context of example 1, you can apply algebra to solve it. So in a jar of coins, there are 30 fewer quarters than dimes. The value of the dimes equals the value of the quarters. How many dimes are in the jar? So the first thing any good story problemer does is define the variables. So the thing it says here is D equals the number of dimes. And this is the number of quarters is 30 less because it used that from, so D minus 30 equals the number of quarters. And we defined it because of the fact that we knew there's 30 less quarters than dimes. All right. And this is the value of the dimes will be 0.10 times the number of dimes equals the value of the dimes. And the reason why that is, of course, is because if I have, let's say, 3 dimes, right? 3 dimes, then 10 cents times 3 would be 30 cents. I'd be able to use that in terms of value of the dimes. Okay. And then the last thing we define here is the value of the quarters. So since this is the quarters, if I multiply that amount by 25 cents, I will have the value of my quarters. Q-U-A-R-T-E-R-S. So a very good starting point for this problem, and the most important part of probably all of your different things is to define the variables algebraically. So the equation, if we read back then again, it says the value of dimes equals the value of quarters. The value of dimes equals the value of quarters. Well, look here. I have a value of dimes algebraically, and I have the value of quarters algebraically. So since those two are equal, guess what? I can create an equation from those to figure out the value of D. So what I've done here is I've simply created an equation. Now we isolate the equation. So we have variables on both sides, but here we have, what do we have? We have distributive property. So we're going to simplify that first. So 0.10D equals 0.25 times D. Take away, what is a quarter of 30? Well, half of 30 is 15. So a quarter of 30 is 7.5. Now, if you don't believe me, you can take your calculator and go decimal 25, a quarter of, which is times, 30 equals 7.5, right? A quarter of 30. So it's minus 7.5. Now we have variables over here, and we have variables over there. Oh, that's not the right button. I'm hitting the wrong button. Help me. Help me, Obi-Wan Kenobi. Oh, I lost my... Oh, everything's going to hell. Heck, sorry. Where is my... There's my smartboard tools. Come on up. Where are you? Oh, okay, I'm back here. Sorry for that. So what we have here, now we have variables on this side, and we have variables on this side. And a general rule of thumb is you get rid of it on the side that has the least amount, but it doesn't really matter because, you know, if I get rid of it on one side. So what I'm going to do, since I already have my value over on this side here, what I'm going to do is I'm just going to take away 0.25D from both sides. It doesn't matter. And for this purposes, I'm just going to keep it like this. So when I do this, I have negative 0.15D over on this side. And over here, I have negative 7.5. Divide both sides by the coefficient. And I end up with D equals 7.5. Remember, I don't need my negatives because I know a negative divided by a negative is a positive. Divided by 0.15 equals 50. So now here's where it pays off. All that hard work that we put into the first of it gives us our answer because we define the variables. So D equals 50, therefore the number of dimes is 50, and the number of quarters is 20, because D minus 30, or 50 minus 30, is 20. And we've solved the problem. Isn't that fun? It's so awesome. So we have 50. Let's look at the show you know, which is going to give you a question that is similar, but it's going to require you to use a different method, or same method. So it says, in a jar of coins, there are 20 more nickels than quarters. The value of the nickels equals the value of the quarters. How many quarters are in the jar? Okay, so give it a go right now. And as you're doing, make sure you define the variables well. Start with maybe, start with Q for quarters. So number of quarters is Q, and take it from there. Okay, we're back. So we're going to start with Q equals the number of quarters. Okay, number of quarters. And it says, in a jar there are 20 more nickels than quarters. So if there's that Q equals number of quarters, then Q, the number of quarters plus 20, will equal the number of nickels. Right? The number of nickels. And the value of the nickels equals the value of the quarters. Well, what's the value of the quarters? How do we value quarters? If there's Q quarters in a jar, what's its value? Well, we have to take the number of quarters, Q, and multiply it by that. That would give me the value of the quarters, right? Because we multiply the number of quarters, Q, by 25 cents, and we get the value of the quarters, Q-U-A-R-T-E-R-S. And likewise, the number of nickels, it's 5 cents multiplied by the number of nickels, and that'll give us the value of nickels. Okay, so what we have here now is a equation that we can create because the value of the quarters and the nickels are the same. So this amount and this amount are the same. So 0.25 Q is equal to 0.05 Q plus 20. So the exact same format in the last time. I'm going to open my distributive property. Now, actually, we could do distributive property, or just like we did in section 8.3, we can divide both sides by this amount here. Let's try that, see what happens. This is kind of fun. So I'm going to divide both sides that. Instead of having that, I'm going to have Q plus 20 over here. And over here, I'm going to actually say, well, what is 0.25? This is actually an easy one, but use a calculator. Divided by decimal 0.5. The answer is it's 5. So when I divide these two, I end up with 5Q. And now what I do is I subtract Q from both sides to get it isolated over here. So I have 4Q equals 20. And then divide both sides by 4, and I end up with Q equals 5. So the number of quarters, going back up here, is 5. And the number of nickels is 25. And we have the answer to our solution. Hopefully that little trick there that we had learned in 8.3 didn't confuse you right here. But if you do have trouble with what I just did there, go back and check out the example 2 lesson in 8.3, and that'll help explain why I did what I did. And everything will be good and happy. Hope you're enjoying the algebra section so far. Remember, extra help is on Tuesdays and Thursdays until 4 o'clock. And if you need extra help, in addition to that, I'm always available at lunch for you.